Hi guys, let's find an expression for electric potential at any general point due to an electric dipole. So in the earlier section we derived expression for electric potential along the axial point due to an electric dipole and along the equatorial point due to an electric dipole. But in this case, we will consider anywhere just at here. Let me consider an arbitrary point at point P. So this point is at a distance r from the middle of the dipole. I wish I would like to find what is the electric potential due to this dipole at this point. So for that, we will consider let this charge at a location A and this charge at location B. Now from charge minus Q, the point P is at a distance of R1. From here to here you can take at a distance of this at a distance of R1. And similarly from this side, if you can take that as from point B to the location to the charge as R2. R2. Now we will write the potential expression because of these two charges. So if we can write electric potential due to minus Q charge, if you can take that as V1 equal to 1 over 4 pi epsilon naught. Here the minus Q upon the distance, let me consider the distance as A to P. Now similarly if you can write the electric potential due to plus Q charge. Due to plus Q, if you can take that as V2 equal to 1 over 4 pi epsilon naught of this time it is a plus Q upon the length B to P. Now if you can take the total potential. Now the total electric potential due to dipole at point P, if you can take that as V equal to, that is 1 over 4 pi epsilon naught minus Q upon AP and plus 1 over 4 pi epsilon naught plus Q upon BP. Now if you can sum up by substituting the what is the value of AP and by substituting what is the value of the BP. So V equal to, I can take Q over 4 pi epsilon naught outside. So here it is minus 1 over A to P. The A to P, the distance I consider as R1 plus from here Q by 4 pi epsilon naught is went out of the bracket. I pulled as common and it's 1 over R2. And if you can take the LCM, V equal to Q upon 4 pi epsilon naught of, take the LCM on the numerator, that gives to me as R1 minus R2 divided by R1 R2. Now from the figure, our task is to find what is the distance R1 minus R2. Suppose if you take from the origin at here, the middle of the length dipole, the length from here to here will becomes as R. The point P is at a location of the R. To find out the value R1 minus R2, suppose if I make a small change in the figure, suppose if I can draw a line at there. Now I draw a line from a point B. Now if you can see, from this location the distance R1 and the distance R2, they both are equal. Now from the location A, and this will becomes the extra length. Suppose if we can take that as, so from here to here, so the extra length I can write them as R1 minus R2. And if this is the extra part as R1 minus R2, and now this lengths become equal. Now if you can write R1 is equal to R2 equal to R. Now I need to find what is this value at here. What is the value of exactly the value of the R1 minus R2. Now if you can take this as at a 90 degrees, since it is a perpendicular, we draw exactly a perpendicular. Now if you can take this a point as K, therefore from right triangle AKB, from right triangle AKB, you can write the cos theta, and we know the AB value. AB value is nothing but the 2A, dipole length 2A, and we need to figure it out what is the value of the AK. Now if you can take as value of the theta, cos theta equal to base by hypotenuse, B by H. So cos theta equal to, here the base value equal to A2K and the hypotenuse value equal to A2B. So therefore cos theta equal to A2K is the value of R1 minus R2, and the AB is nothing but hypotenuse 2A. So therefore R1 minus R2 equal to, we got a value 2A cos theta from the figure. So we can substitute that values, the two values, one is R1 minus R2. So this is the two values I can get from R1 and R2 values, it will becomes equal, and one more value we got it at here, that is R1 minus R2. So the two values we got it from by considering an equal length by drawing a perpendicular bisector from point B on the side of A to P. Now if you can substitute those values at here, the potential V equal to Q upon 4 pi epsilon naught of R1 minus R2 equal to 2A cos theta, and R1 R2 becomes R square. Since from figure R1 equal to R2 equal to R, so one more time you can observe that carefully. By drawing this perpendicular bisector at here from point B to on side A to P, so we made these three distances are equal. So now the R1 distance and R2 distance made it equal to R. Now we also figured out what is the extra distance from A to P. Here it is R1 minus R2. So that we found out at here by considering the right triangle AKB. So from that we got it by using cos theta terms. So finally we got the final value. So if you can write these expressions, V equal to 1 over 4 pi epsilon naught of, if you can send the q inside, it will becomes 2qa cos theta upon r square. In the place of the 2qa, you can write that as nothing but dipole length, since P equal to 2qa. So finally, V equal to 1 over 4 pi epsilon naught of P cos theta upon r square. So this is the expression for at any point due to an electric dipole. So I want to make one small change in this expression, that it as, suppose in this expression if I multiply and divide with r on the both numerator and denominator, so we can get that as V equal to 1 over 4 pi epsilon naught, it becomes, so P cos theta times r upon, on the denominator becomes r cube. So why I want to do that as, so I want to check one small thing, so you will understand by the end of the expression. Now here you can write this. So if you can see this, it is in terms of P, dipole moment is a vector position and r is also a vector. Now the dot product of two vectors, I can write a bar dot b bar equal to ab cos theta. Now I can write that as 1 over 4 pi epsilon naught of, I can write in terms of P bar dot r bar upon r cube to simplify the expression. So this is the simplified expression of the electric potential due to at any point, at any point. So if it is at any point, our axial point is also, this formula should work, and along the equatorial point also this formula should work. So to find at axial point, what is the angle between P and R? What is the axial point? If you can take, this is the two charges, the axial point is along in this direction. So the position vector and the dipole moment direction, they both are in the same direction. If you remember, the dipole moment is also having the direction. The direction of the dipole moment is from negative charge to positive charge. So now the angle between these two, the theta will becomes theta equal to 0 degree. If theta equal to 0 degree, what we can get? So we can get cos 0. Cos 0 will becomes, value goes to 1. So I can write at an axial point theta equal to 0 degree. So potential V equal to 1 over 4 pi epsilon naught of P dot R cos 0 degree upon by R cube. So we can get cos 0 value 1. So potential V equal to 1 over 4 pi epsilon naught of P times R by R cube. Now you can cut 1 R in the R cube terms. Now the final expression V equal to 1 over 4 pi epsilon naught P by R square. Yeah, this is the expression for an electric dipole potential due to an electric dipole along the axial point, which is correct. Now let us find the same along the equatorial point. Now if you take equatorial point, along equatorial point, how you can consider equatorial point? suppose this is a dipole length, if it is a minus q charge and the plus q charge, and the equatorial point is should be perpendicular to the dipole axis, exactly 90 degrees. So it is the point P, the distance r. Now if you can take the position vector and the dipole moment vector, so the dipole moment vector and the position vector are making an angle of 90 degree. Now if you can take the general expression for the potential V equal to 1 over 4 pi epsilon naught of P dot r cos theta upon r cube. So for equatorial point, the angle between P bar and R bar, so here theta equal to 90 degree. So cos 90 degrees, that implies cos 90 degrees value will becomes 0. If cos 90 degrees equal to 0, whatever the potential value, so potential value also will become 0. P r cos 90 degree upon by r cube. So we can get this total value is equal to 1 over 4 pi epsilon naught of P dot r of 0 upon r cube. So finally we can get that potential V equal to 0. Yeah, it's correct. The potential is 0 for an electric dipole if the point is along the equatorial point. So we can derive anyway for the axial point, for the equatorial point. If you take the potential for an electric dipole by using this general expression. So in this general expression we will get that in terms of the dot product of dipole moment vector and position vector.